All right, good morning. Just recording this lesson for you guys today. It should go fairly quick. And when you get done with the video, then just start working on the 10.4 assignment on your assignment sheet. Okay, the first thing we're going to talk about is the difference between central angles and inscribed angles. So up here in red, it says a central angle is when you have a vertex on the center of the circle. And when that happens, the arc will have the same measure. So an example of that would be down here. This is an example of a central angle, angle ADC, because the vertex of the angle is right on the center of the circle. If I wrote it like this, angle ADC, see how that middle letter D, that's the center of the circle. So that's a central angle. Whatever this angle measure is, like if we pretend it's 50, whatever that angle measure is, then so will the arc that it's grabbing onto be. So if that angle is 50, then arc AC would also be 50 degrees. So the central angle and the arc would be the same. And we've done problems like that already. Well, the new thing now is an inscribed angle. That's when the vertex is on the circle. So an example of that would be right down here. So you see how this angle ABC, the vertex is B and it's on the circle. It's not on the center, it's actually on the outside of the circle, the outside edge of the circle. Now this angle right here is going to be half of the arc that it's grabbing onto. So again, think of this as like a person. Here's the person's head maybe, and here's an arm with a hand, and here's another arm with a hand, and those two hands are grabbing onto this arc. So this arc, it will say it's 50, just like on that last problem. Well, this angle then will be half of that. So this angle would be 25. So the measure of the inscribed angle is half the measure of the intercepted arc. When you see this word intercepted, sometimes I think of like football. So when you intercept a pass, you catch the pass, right? So this little, like, imagine like a little stick person. He's grabbing on here and he's grabbing onto this arc, intercepting the arc, if you want to think of it that way. So when it's an inscribed angle, that angle will be half of the arc. Okay, so now this is just kind of applying the same thing. If you look at the green angle, what arc is that grabbing onto? So imagine that this is a hand, and this is the arm with a hand, and it's grabbing onto arc AC. That angle right there will be half of the arc. So if I want to, or think of it, the arc will be twice as much as the angle. So if I want to figure out this arc, I would take 36 and I would multiply it by 2, and that would be 72 degrees. This arc right here would be 72 degrees. The angle is half of the arc, or the arc is twice as big as the angle. But if you look carefully, you see this blue angle. It's, if you think of this as an arm, and that's a hand, and here's another arm, and that's a hand, you see how it's grabbing onto the same arc? So therefore, this angle should be half of 72. Half of 72 is 36. So if this angle right here is the same as this angle, the blue angle and the green angle are the same, because they're grabbing onto the same arc. So if I was to complete the sentence, it says, if two inscribed angles of a circle intercept the same arc, then the two angles are the same or are congruent. Just like in this problem, angle ABC is congruent to the green angle ADC, because they both grab on to arc AC. Okay? Now what this is talking about is if you were to take and inscribe a triangle into a circle. Inscribe means that the vertices of the triangle are on the circle. So A, B, and C are on the edge of the circle, and those A, B, and C are the vertices of the triangle. So that's considered inscribed in the circle. And then it says, if a right triangle is inscribed in the circle, then the hypotenuse is the diameter. And then it goes just the opposite. So if you have a diameter, okay, this is a diameter. If you can clearly see that that's a diameter, okay, and you have a triangle, then that diameter is also the hypotenuse. So if this is the hypotenuse of the triangle, then the angle across from it should be a 90-degree angle. So that 3x should be 90 degrees. So if I divide by 3, then that would mean that x equals 30. So if you notice a triangle inscribed in a circle, and one of the sides of the triangle is a diameter, like shown here, then that diameter is also the hypotenuse. So then the angle across from it will be 90 degrees, a right angle. Then if you have a quadrilateral, so a four-sided shape inscribed, so do you see how all four of these vertices lie on the circle? That's what inscribed means. Then it says that the opposite angles are supplementary. So these two angles are opposite of one another, so they would be supplementary, meaning they add up to 180. So x plus 80 would add up to 180 degrees. And if we solve for x, we would just subtract 80. So that would mean that x equals 100. And then we have another set of opposite angles. These two are opposite of one another. They should add up to 180. So the y and the 120 should add up to 180 degrees. And when you subtract 120 from both sides, you get 60. So y would equal 60. So if you have a quadrilateral four-sided shape inscribed in a circle, the opposite angles will be supplementary. Okay, so this is just kind of putting it all together and looking at some examples. So this blue angle right here, see this vertex? It's on the circle. It's not on the center, it's on the circle. So this angle right here will be half of this arc that the angle is grabbing onto. So this angle of 5x plus 4 will be half of 208. So the angle 5x plus 4 is equal to half of the arc, 208. Now I'm going to solve for x. Well, half of 208 is 104. And if I want to get the x alone, I need to get rid of this 4. So that means that 5x equals 100. And I'm going to divide by 5. So x equals 20. So this angle is half of the arc. Okay. Now for the next problem, we're going to look at trying to figure out what angle BAC. So B, then go to A, then go to C. This is the angle we're looking for. Okay. Now sometimes it helps to think of, well, what arc is it grabbing onto? It's grabbing onto arc BC. So just kind of keep that in mind. Now they gave us this 142 degrees. This angle right here is 142 degrees. They're giving us that for a reason. So this blue angle is 142 degrees. This blue angle, though, is a central angle. Do you see how the vertex is on the center? That means that it will be the same as the arc it's grabbing onto. So this blue arc will also be 142 degrees. Central angles are the same as their arc. Well, now it also helps if you can look for a diameter. So this right here is a diameter, BAD, and diameters split the circle in half. So the arc that this diameter is grabbing onto is this whole arc right here. That whole arc is 180. Okay, so can you kind of see here? Maybe let's see if I can experiment with this just to help you visualize a little bit better. Okay, let's try it. Okay, if you just focus on that for a second. Do you see how the whole thing is 180? The blue part's 142. If I want to know what that red part is, I would take the whole thing, 180, and I would minus the blue part, 142. And that will give me the red part, which would be 38. So this arc up here is 38 degrees. Okay, now I'm going to get rid of that cover up. Now look at what we have. This is an inscribed angle. Let me get my pen, sorry. This is an inscribed angle. The vertex is on the circle. So this angle will be half of the arc it's grabbing onto. The arc it's grabbing onto is 38 degrees, so this angle will be half of 38 degrees. So that angle will end up equaling 19 degrees. Angle BAC is 19 degrees. So this is a good problem because it involves central angles. The vertex on the center is the same as the arc, and it involves inscribed angles, which are half of the arc. Okay, we're running low on time, so I want to do one more really quickly. See this angle right here? If you imagine those are arms, they're grabbing onto this arc, right? We'll look at the other angle. This angle right here, imagine those are arms. They're grabbing onto the same arc. So if they're grabbing onto the same arc, then that means that these two angles are the same. So 5x minus 2 is the same as 80, and you can solve that. You can add 2 and divide by 5, and you'll get 16.4. Okay, I'm running out of time. This last problem you can try to do on your own, and then work on the homework, and I'll see you on Monday.